Okay, hello everyone. I welcomes to all in our lecture series on mathematical physics, that is your core paper 8, belongs to 4th semester B.sc Physics Honors CBCS model. In our last class we have been discussed this question number 8 and question number 9. In detail we have been discussed. Okay, and we found one important result, that whenever we are moving from in to out, we are getting principal part of the Lorentz series only, and moving from out to in case, we are getting analytic part of the Lorentz series. Same we found in question number 8. Out to in, only analytic part. Here in to out case, we are getting only the principal part. Okay, so I suggest keep this result in your mind, which is very important to solve the numericals. Okay, so now we are going to move our next question, that is your question number 10, also very important question. Find Lorentz series of the function fz equal to 1 by z plus 3 into z plus 5. There are 3 bits. First we have to find out for z mod less than 3, then z mod greater than 5, then z mod in between 3 and 5. In detail we are going to discuss this question. Carefully you have to watch and do your note for your exam. Okay, now so before we are going to find out the Lorentz series of this function, first we are going to do its partial fraction. Here given function is your 1 by z plus 3 into z plus 5, that is your fz. If I am going to consider this function, the singular points, clearly we can find that z equal to minus 3 and z equal to minus 5 are the two singular points. You can put z equal to minus 3, this term will be 0, that function could not be defined. Z equal to minus 5, I'll be put over here, this term will be 0, that means denominator will be 0 and function could not be determined. So these 2 points, minus 3 and minus 5, are the singular points of this function. Now we are going to go for the partial fraction. So here detailed step of the partial function of this function I done here. You have to write in your note. Okay, so given function is your 1 by z plus 3 into z plus 5. This can be written as a by a is some constant, b is some constant, by z plus 3 plus b by z plus 5. So for the partial fraction we need to find out a and b value. You just add these two terms, we can find z plus 3 into z plus 5 in the denominator, and the numerator will be a into z plus 5, b into z plus 3. That implies this term 1 by z plus 3 into z plus 5 will be equal to here az bz, that means a plus b whole z. Okay, and another two constant terms, that is your 5a and 3b, 5a plus 3b by z plus 3 into z plus 5. Here we consider a and b are the arbitrary numbers, but here you can see the left hand side, the denominator of left hand side is equal to denominator of your right hand side. That means the numerator should be equal. The numerator, the coefficient of the different powers of z should be equal. That means here z to the power how much, 1. That means left hand side, wherever the z to the power 1 will be there, the coefficient of that coefficient should be equal to a plus b. Here in the RHS the coefficient of z is a plus b, and if in the LHS some coefficient will be there, if z term will be there, then the coefficient will be matched. But here you can see that in your LHS there is no z term, so a plus b will be how much, a plus b will be equal to 0, and this is the constant. 5a plus 3b is the constant term. Constant term will be how much, 1. So 5a plus 3b equal to 1. Okay, this detailed partial fraction we have been discussed whenever we done the Taylor series. So this is the simple partial fraction. But if you are going to search the video Laplace transform, in that videos we done variety of partial fraction. Okay, so here we found the two equations, that is the coefficient of z equal to a plus b will be equal to coefficient of z of the left hand side, but there is no z term, so a plus b equal to 0, and this is the constant term, that is your 5a plus 3b will be equal to 1. Now we are going to solve these two equations to find the a and b. So here a plus b equal to 0, so I multiplied 5 with this equation and subtracted these two equations. So 5 into a plus b equal to 0, then subtracted. If I will subtract, then here you can see 5a, so minus 5a plus 5a got cancelled, and here minus 5b plus 3b, that will be minus 2b, will be equal to 1. That implies b will be minus 1 by 2, and as a plus b equal to 0, so a will be equal to minus, a will be equal to plus 1 by 2. So here mistakenly written. So a plus b equal 0, b we found minus 1 by 2. So this will be a minus 1 by 2 will be equal to 0 because a plus b equal 0. So a minus 1 by 2 will be equal to 0 and a will be equal to 1 by 2. So here we found b equal to minus 1 by 2, a equal to 1 by 2. Hence here if I will substitute instead of a 1 by 2, b minus 1 by 2, the function 1 by z plus 3 into z plus 5 will be 1 by 2 into 1 by 2 taken common. So it will be here a is your 1 by 2. So 1 by 2 taken common means 1 by z plus 3. B is your minus 1 by 2. 1 by 2 taken common means minus 1. Minus 1 by z plus 5. So this is the partial fraction result of this function. That means Lorentz series of this function means Lorentz series of this function. Then Lorentz series of this function. Then we have to subtract both the series. Okay. Now we are going to find out the Lorentz series of this one or this one for the first bit. First bit is given the region that z mod less than 3. In this region, we have to find out the Lorentz series of this one. Okay, that means we have to find out the Lorentz series of 1 by z plus 3, then 1 by z plus 5, then we are going to subtract, and 1 by 2 is already multiplied. So 1 by 1 we are going to do. Carefully you have to watch. Okay. First of all, we are going to define the range whatever given by mod function. Here you can see range has been given that z mod less than 3. In this range, we have to find out the Lorentz series of the given function. So if we consider the mod function, the given range is what? Z mod less than 3 means we have to consider this range. That means minus 3 to plus 3. That means Z should be less than 3 and greater than minus 3. Or this range can be found by considering circle equation. That means if we consider, say clearly I written, if we consider Z mod less than 3 is the equation of a circle, then z mod less than 3 can be written in this format, that z minus 0 mod less than 3. Here 0 is the center and 3 is the radius. Okay, so here I drawn that circle with radius 3, center 0. I drawn the circle. So this is the complex plane, this is the 0, and radius is 3. 1 2 3. But as per the question, we have to consider the region just below the 3, just below the 3. That means this region. Okay, so here this region we found by two ways, by considering the mod function z mod less than 3. Here if I am going to consider this one, z mod less than 3, that means minus 3 to plus 3 range. Here also same thing. Here after drawing this circle, minus 3 to plus 3 is the range by considering only a real axis. But if I am going to go with this circle method, then after drawing this circle, I found that less than 3, that means radius will be less than 3. Less than 3 means this region we have to consider to find the Lorentz series of the function. Okay, so from question or from figure, it can be found that we have to find out Lorentz series about z equal 0, or that is considered as your z0, because I told in the previous class that here you can see, if in the question is not given about which point we have to find out Lorentz series, particularly region based question or annular region based questions, then we have to consider z0 is that point which is the common center of the circles. I written as a note itself, and I suggested that you have to remember this one, which will be most essential. Okay, so here in this case, also in the question not given about which we have to find out the Lorentz series. So for this question, you can see in the figure, the center is at 0. Okay, and here only one circle is there and center is at 0, and this center will be considered as z0. Z0 will be equal to 0 for this question. Okay, if I draw the region itself, the center will be at 0. That means obviously we have to find out the Lorentz series of this function about z0 equal to 0. Okay, so I suggest that you just go for this method, circular method. That means you just drawn the circle, means automatically you can found where about which point I have to find out the Lorentz series, and what are the other your singular points, everything you can found, and the region also you can found. Okay, so I suggest that you just go through this circular method to find the region, because if you are going to practice to find out the region range by circle by considering circle, then it will be easy to solve other questions that we are going to discuss in our next class. Okay, so here you can see the z0 is not the singular point of this function. Okay, but about z0 equal to 0, we are going to find out the Lorentz series. And what are the singular point of this function? First, at the beginning, we have been discussed that -3 and -5. So after drawing this circle, here you can see this circle just interacted just below the -3. Okay, and another singular point will be at -5 here. The two singular points, one is will be at -3 and another will be at -5. And we already discussed that whenever we are going to move inside out or outside in case, in to out to in case, at that time we have to consider the point, starting point is our z dash. So z dash is the starting point. Either we have to move for out to in or in to out, what we already discussed in our previous lectures. Okay, now we are going to find out first Lorentz series of 1 by z plus 3. It's 1 by z plus 3. Okay, first we are going to find out the 1 by z plus 3, then we are going to go for 1 by z plus 5 for this particular region first time. Okay, so for this one by z plus 3, clearly it's a singular point, sp means a singular point. Okay, s dot p or sp, wherever I written some, that means you just consider that is the singular point is at where is at z equal to -3. But we have to find out Lorentz series about z0 equal to 0. Okay, so from the figure here you can see z0 is your 0, z dash will be -3. So z dash is your -3 and the region is -3 to +3. Already we discussed the range is your -3 to +3. So if you are standing at -3 and trying to move in that specified region, that region means this one. So what is your work is your out to in work, out to in. So any point, suppose arbitrary point z inside this region, and you are trying to move from one of the singular point, that is your -3, from -3 to any arbitrary point z. That means your work is out to in. Okay, out to in case, or you can consider this is the so-called tricks what I derived from your Lorentz series. So for out to in case means what we are going to consider any function. In general, we can write 1 by z dash minus z0 minus z minus z0, right? Same thing, it has been written z dash minus z0 1 by z plus 3. Now for out to in case can be written as z dash minus z0 minus z minus z0. Z dash is your -3, z0 is your 3, and z is the arbitrary point, z0 is 0. Okay, now here after this step you just match is the initial function is same with this one, because we are trying to write this one in this format. We are trying to write this initial function with in this format what we have been studied in our Lorentz series theorem. Okay, so if I'm going to match, here you can see -3 minus z. That means this will be in the form of this one by -3 minus z, but we have 1 by z plus 3. If I will be multiply one minus, then it will be exactly matched with the initial function. So I done that one. I multiplied minus. Okay, so here now -1 by -3 minus z. What is the first term? -3. Second term minus z. Whatever the first term, I have to take common from these two terms. This is the most important. Okay, first term is your -3 taken outside. The inside terms are 1 plus z by 3. So minus got cancelled, and we found 1 by 3 into this one. Here you can see z by 3 for this region always less than 1. You can check, no problem. Z by 3. So you just consider any point inside this region. The z by 3 will be always less than 1, right? So for the simplicity, consider that arbitrary point on the real axis. Okay, so consider -2 by 3 less than 1. Consider this point 2 by 3 also less than 1. Consider just below 3, that means 2.999 something, or 2.9. You just consider just below the 3, 2.9, because the region is less than 3, no? So you just consider 2.9 by 3 also less than 1. So here z by 3 is always less than 1. If it is so, we have to direct write that the series of this one plus z by 3 is nothing but summation over n equal to 0 to infinity minus 1 to the n z by n to the power n, right? Okay, because these things already have been discussed several times, that if we have like this 1 by 1 minus x, then it will be, and x is less than 1, it will be n equal to 0 to infinity summation x to the power n. This will be minus 1 to the n x to the power n when 1 plus is there. But here condition is that x should be less than 1. And here we found that x is, instead of x, z by 3 is there. Got it? Now we are going to go for finding the Lorentz series of 1 by z plus 5. Its singular point exists at where? Minus 5. That means this point will be considered as your z dash, from where you are going to move to the specified region. So from the figure, z0 is your 0. Okay, and here I drawn a figure that you are standing at where? Z dash equal to minus 5, moving into the region where you are standing. You are standing at minus 5. You are trying to move inside this region. That means out to in case. This is out to in case. And for this case, z dash is your minus 5. So this is also case. This is the case of your out to in. So we know that in case of your out to in case, the in general the function or the denominator of the function will be written in this format: z dash minus z0 minus z minus z0. So this 1 by z plus 5 will be written as in general 1 by z dash minus 0 minus z minus z0. Here z dash is your minus 5, z0 is your 0, and z is the arbitrary, z0 is your 0. By substituting all, first work is that we have to just match. Is it matched with our initial function? Here you can say this will be minus 5 minus z, not matched. If I will multiply minus 1, then it will be matched. So I multiplied. This is the procedures. Okay. Minus 1 by minus 5 minus z. Now, what is the first term? Minus 5. Second term? Minus 7. What will be the, whatever the first term, blindly you take the common from these two terms. Minus 5 taken outside. Then we found 1 plus z by 5. You can check z by 5 always less than 1. If you can say z by 5, any point, suppose you can consider inside this region, you consider 3. 3 by 5. 3 by 5 will be less than 1. You consider here 2.9. 2.9 also less than 5. Less than 1. So here for this particular region, z by 5 will be always less than 1. Okay. If it is so, then this one, the series of this one, that is your 1 by 1 plus z by 5 will be summation over n equal to 0 to infinity minus 1 to the power n, z by 5 to the power n. This is minus got cancel, and 1 by 5 we got. Okay. Now here we found that for this particular region, z mod less than 3, we found the Lorentz series of 1 by z plus 3 is your this one, and Lorentz series of 1 by z plus 5 is your this one. Finally, the Lorentz series of the given function, main function, that is your 1 by z plus 3 into z plus 5 will be how much? Because z plus 3, 1 by z plus 3 into z plus 5 is nothing but 1 by 2, 1 by into 1 by z plus 3 minus 1 by z plus 5. Separately, you have to write the series only. 1 by 2 written over here. Then 1 by 3, 1 by z plus 3 series is how much? This one. Simply I have been written over here. Then minus 1 by 5, 1 by z plus 5, 1 by z plus 5 Lorentz series is this one. Simply I have been written. Okay. Got it? Okay. If you want to write in the expansion format, also you can write. Here you can see alternative terms will be plus or minus, because minus 1 to the power n. If I put 0, n equal to 0, then first term will be 0, the first term will be 1, because minus 1 to the power 0 is 1, z by 3 to the power 0 also 1. Second term will be minus 1 to the power 1 means minus, third term will be plus, like this. And its power also is going to be increased. So if you are going to write in the form of expansion form of the Lorentz series of this function, then this will be, that will be, here you can see 1 by 2 already is there, 1 by 3, 1 by 6, and you just open this expansion. Here 1 by 2 into 1 by 5 means 1 by 10. So 1 by 6 this series minus 1 by 10 this series. Okay. Now we are going to go for the next region or next bit, that is your z mod greater than 5. Okay. Here we consider mod function first. First we have to find out the region, in which region exactly we are going to find out the Lorentz series of the given function. So actually given, mathematically it has been given that z mod greater than 5. So if I am going to consider z mod function, what is the meaning of z mod greater than 5? Means z less than minus 5 and z greater than 5. इसका मतलब यही है कि z 5 से ज़्यादा हम लेंगे और minus 5 से कम. That means if I am going to consider the complex plane, that means according to this mod function, we have to consider the values of z above 5, and below minus 5. This one. That means this region, this outer region. if I'm going to consider the circular equation method, how I'm going to get this region, outer region, you just watch. Okay, if we consider z mod greater than 5 is the equation of circle. यदि ये अगर के सर्कल का इक्वेशन हम मान ले, then z mod greater than 5 can be written as z minus 0 mod greater than 5. Here this 0 is represents the center and this is your so-called radius. See, we are going to consider the region above 5. If we are going to consider equal to 5, that means radius will be how much? 5. So considering radius 5, 1, 2, 3, 4, 5, I draw on a circle and center is at 0. सेंटर 0 है, 5 का रेडियस लेके मैं एक सर्कल ड्रॉ कर लिया. उसके बाद 5 से ज़्यादा जो भी रीजन होगा ना, वही मेरा रिक्वायर्ड रीजन है. इन दैट रीजन वी हैव टू फाइंड आउट द लॉरेंट सीरीज ऑफ दैट पर्टिकुलर फंक्शन. Okay, so this is the region. That means in this region we have to find out the Lorentz series. Again I'm going to tell to you that you just remember in the circular method to find the region. Okay, now as per the question, z0 is what? 0, which is not the singular point of the given function. Okay, see, these things I have been written for your note, but for your exam you should not write these things. For exam, how and how much you have to write for this question, particular question, I'm going to tell to you at the end of this video. See, do not fear that for this particular question, this question will be asked for 6 mark. This question, this entire question. But for the 6 mark question, 1, 2, 3, 4, 5, 6 page we have to write. So do not fear. What exactly you have to write in your exam, and you are going to get the full mark, that I am going to explain at the end of this video. For that, you should not worry. But in detail, step by step, I written that whenever you are going to follow your note now, you can understand easily. Okay. Now, finding LS of, we found the region as per the question. Now we are going to go for the finding the LS of 1 by z plus 3. Then we are going to find out the LS of z plus 5, 1 by z plus 5. Then we are going to, finally we are going to subtract. That means finally we have to substitute the Lorentz series of this one here and here. Okay. Now, here you can see for 1 by z plus 3, singular point is minus 3. That means z dash is minus 3. Okay, you just recall that wherever your singular point, that will be considered as z dash, and from that point you start motion into the specified region. Okay, so here singular point of this function is your z dash, that is your minus 3. Minus 3, where is minus 3? Here, minus 3. You just stand over there, you just wait. Okay, and z0 is your 0. Now for this situation, what is the region? In which region we have to find out? This is the region. You are standing here, and you are from here, you are moving this side, means out. You are out, moving outward. Outward means into out motion. I written this vector, what I represented, that is your into out motion, into out motion. So for this case, into out motion we are going to consider. Little I have been written from figure z0 0 standing at z dash equal to minus 3, moving in the given into the moving into the given region is what type of case? That is your into out case. That is the so-called tricks. See, tricks you should not write in your exam. Here I written for your note. Okay, तुम एग्जाम में मत लिखना है. एग्जाम में जितना शॉर्टकट करके लिखना है, क्या क्या लिखोगे मैं बता दूंगा, नो प्रॉब्लम. So hence 1 by z plus 3, if it is into out, what we have to write? Z minus z0 minus z dash minus z0. Same thing I have been written. 1 by z plus 3 will be written in this format, that 1 by z minus 0, z0 minus z dash minus z0. Z0 is 0. So 1 by z plus 3 will be equal to 1 by z minus 0 minus z dash is your minus 3 minus 0. Here, now I am going to check what I have been done, what I have been written. That is exactly match with the original function or not? Yes, it is matched. Here you can see z, this is minus, minus, plus. So this is exactly match. That means 1 by z plus 3, we found there is no need to multiply minus, because this is exactly match. And here you can see what will be the first term. First term is what? First term, here there are two terms, z and 3. First term is the z taken outside. We found 1 plus 3 by z, and here 3 by z always be the less than 1. You can check any number, you can take here. For the simplicity, you just take this arbitrary point on the real axis. So this is minus 5. You just consider minus 5.1. Minus 5.1 you can just consider. So minus 5.1 here. 3 by minus 5.1 less than 1. If it is so, another point you can check. So here you can check this point. Plus 5.1 also less than 1. 6 you consider 6 also less than 1. Okay. So 3 by z will be always less than 1 for given region. So if it is so, then 1 by 1 plus 3 by z series will be what? N equal to 0 to infinity minus 1 to the n 3 by z to the n, because this one, if 1 by 1 minus x is there, 0 to infinity x to the n, 1 by 1 plus x minus 1 to the n x to the n. But condition is x should be less than 1. Here 3 by z is less than 1. Instead of this x, we have to write 3 by z. Okay, so this is the series or the so-called Lorentz series of this function in the given region. Now we are going to go for the Lorentz series of 1 by z plus 5. Here for this function, z dash is where? Minus 5. That means here minus 5. Okay, minus 1, minus 2, minus 3, minus 5, 4, minus 5. You stand over there at the minus 5. Where you have to move? You have to move this region. That means into out you have to move. Okay, from the figure z0 is 0, and standing, this figure is telling that standing at z dash equal to minus 5, moving into the given region is the what type of situation or case? Into out case, so-called tricks. If into out, we have to write the main function 1 by z plus 5 in the form of 1 by z minus z0 minus z dash minus z0. So here z0 is your 0, z dash is your minus 5. Now we are going to check that it is exactly same with the original function or not. Here you can see this is the 1 by z plus 5. Original function is 1 by z plus 5. No need to multiply minus 1. And the first term is here you can see z. Just take a common from these two terms. We can find z into 1 plus 5 by z. Here 5 by z always be less than 1. 5 by z always less than 1 in this region. You can consider 5.1 itself. See, this is the arbitrary point. Now consider the arbitrary point on this real axis. It will be easy for you. Consider above just minus 5, minus 5.1. Okay, minus 5.1 you just consider minus 5.1. 5 by minus 5.1 or 5.1 less than 1. Okay, so if so here if 5 by z is always less than 1 for this given region, as this is less than 1, so this one 1 by 1 plus 5 by z series can be written as 0 to infinity minus 1 to the n 5 by z to the power n. Repeatedly I am going to tell to you that you have to remember this one. 1 by 1 plus x will be the so-called Taylor series will be equal to 0 to infinity x to the n. 1 by 1 plus x minus 1 to the, these things already we have been discussed in our Taylor series and there are Lorentz series theorem. But at least these two you have to remember, because you just recall that whatever the numerical, we are transforming all the numerical into this format, because we know what will be its what series. So after transforming any function to this type of situation, we can easily write it's a series. You got my point? Any, you just recall in Taylor series, Lorentz series, whatever we have been discussed the numerical, we are transforming the function into this type of format. So after writing in this format, we can directly write this summation series. Okay, so I suggest at least these two series you should remember. Now we found 1 by z plus 5 about in the given region. In the given region, that is your z mod greater than 5 Lorentz series, how much we found? 1 by z, and this one 1 by 1 plus 5 by z is your this one 0 to infinity minus 1 to the n 5 by z to the power n. Right now here for the for 1 by z plus 5 Lorentz series we found this much, and Lorentz series of 1 by z plus 3 we found this one. So finally what will the Lorentz series of 1 by z plus 3 into z plus 5, because after partial fraction we found this one 1 by z plus 3 into z plus 5 is nothing but this one. Okay, this one you can consider itself this is your equation number 1. We have to just substitute the Lorentz series of 1 by z plus 3 here and z plus 5 1 by z plus 5 here. Okay, so what will be the final Lorentz series of this function? Will be 1 by 2. Already 1 by 2 is there. Here you can see 1 by 2 is there, 1 by 2 is there, whole into this one for 1 by z plus 3 Lorentz series is this one. substituted, then minus 1 by z plus 5 Lorentz series is this one, substituted. Okay, or I'm going to write this is equal to nothing but 1 by 2 1 by z plus 3 minus 1 by z plus 5. Okay, it will better 1 by 2. This is equal to, here also I'll be right, means it will better here z plus that is your Lorentz series of this one. This is nothing but 1 by 2 of 1 by z plus 3 minus 1 by z plus 5. Okay, will be equal to this much, right? Okay, so finally we found the Lorentz series of the function this one equal to this one in the form of expansion. If you want, you can write it will be this one, 1 by 2 multiplied with this. And here we are going to examine one thing, that for z plus 3 and for z plus 5 we got the case that is your into out case. So into out case, here if I'm going to consider this one, we found only the principal part. Here you can see this is the principal part, there is no analytic part. Here z to the power minus n is there. Here 5 by z to the power n means z to the power minus n. Negative integer power of z is there, or we can write this one. Here you can see this one, what we can write, minus 1 to the n 5 by z minus z0 to the power n, or we can write minus 1 to the n 5 into z minus z0 to the power minus n. What is this? Negative power of z minus z0 means principal part. So here into out case, wherever we are going to interact, no, we can get only principal part. There is not going to be get that for this situation we are not going to get any type of analytic part, right? Here also you can see that here this one for 1 by z plus 3 also we consider into out. What we found minus 1 to the power n, 3 by z can be written as 3 by z minus z0 to the power n, or minus 1 to the n 3 into z minus z0 to the power minus n. What is it? This is principal part. We not got any type of analytic part of the Lorentz series. So keep in your mind that if wherever we are considering into out case, for that case we are going to get the what? Principal part, right? Principal part of the Lorentz series, right? Now we are going to go for another bit, that is your range has been given that 3 to 5, z mod 3 to 5, third eye. Okay, yes, this one. So to find the Lorentz series of a function in a given region, like this type of thing, this type of region, if it is given in the question, the most important thing is that we have to find out the region first, or range so called. So for that, what we have to do, we can consider the so-called mod function. As per the mod function, we can determine the region, or we can consider the circular equation method. Okay, circular equation method. Both the method I considered, but I suggest always that you just remember how we are going to find out the region or range by considering the circular method, considering the circular equation method, right? So here by two method I have been determined the region or range. First we are going to consider the mod function. Here you can see, if I am going to consider z mod less than 5, what is the range? That is, the range is your minus 5 to 5. Then I am going to consider z mod greater than 3. Z mod greater than 3. Here you can see z mod greater than 3 means z is your less than minus 3 and z is greater than 3. Okay, z mod greater than 3 means z value we are going to take greater than 3 and z value less than minus 3. Already we discussed for this case. Z mod greater than 5 means z value will be less than minus 5 and z value greater than 5. Same thing here I have been written. So if I'm going to consider the complex plane and z and this region or range for z mod less than 5 means minus 5 to 5 I have to consider. Minus 5 to 5, that means minus 5 to 5 I'm going to consider. But another condition is that z should be greater than 3 and z should be less than minus 3. So z should be greater than means z should be greater than 3. These values are going to be considered, and less than minus 3 means these values are going to be considered. By first condition, Z should be in between -5 to 5. In between -5 to 5. That means we can consider 0, 1, 2, 3, all the points. But by considering the second condition, that Z mod greater than 3, that means Z values are to be considered less than -3. So less than -3 means these points are going to be considered. If above -3 points are not to be considered, and Z is greater than 3 means above 3, what are the points that we are going to consider? So -3 to 3, the region is going to be cancelled. Okay, so this is our region in which we have to find out the Lorentz series of the given function. Now we are going to go for the circular equation method. Here we can consider this one is the equation of circles. Circles means this one. If I'm going to consider, here you can see we can write this one as like this: 3 less than that of the Z minus 0. Here 3 less than Z minus 0 mod less than 5. So here Z minus 0 means here 0 is the center. This is the one, this 5 is represents one radius of one circle. This is another radius of another circle. So 5 means larger radius, 3 means smaller radius. That means we are going to draw the two circles having radius 5 and having radius 3. Here you can see, if I will draw a circle having radius 5, here 1, 2, 3, 4, 5, and another circle 3, the region in between the two circles is our required region in which we are going to find out the Lorentz series of the given function. Got it? So how much it is easy as compared with the mod function, you just compare. Okay, so only for that I suggest that you just remember this is circular equation method to find the region. Okay, so here the given function is 1 by z plus 3 into z plus 5, and by considering partial fraction we found this one. And first we have to find out the 1 by z plus 3 Lorentz series, and then 1 by z plus 5 Lorentz series. Then we have to substitute over here. Finally we are going to get the Lorentz series of this one. So finding the Lorentz series of z by 1 by z plus 3. So from this figure you can see that z0 equal to 0, because may you remember I told previously that if in the question is not given about which point we have to find out Lorentz series, particularly region based or annular region based questions, then we have to consider Z0 is that point which is the common center of the circle or circles. Here common center of these two circles is 0. Hence we are going to consider Z0 equal to 0. Z dash for this function, Z dash is your -3. You just stand over here at -3. You are trying to enter this region. That means what is the work? Work is your in to out. In to out. छोटा से बड़ा मतलब that means -3. Here तुम थोड़ा इधर अंदर में कहीं पे हो और बाहर जाने की कोशिश कर रहे हो. That means it is expanding in to out like that. You just perceive inside yourself, which is the so-called tricks. If in to out case is going to be applied over here, then 1 by z plus 3, the Lorentz series of 1 by z plus 3 will be written in this format, that 1 by z minus z0 minus z dash minus z0 into out z minus z0 minus z dash minus z0, right? So here z0 is your 0 and z dash is your -3. After substituting all the values, you just compare that is it same with the initial function. Yes, it is same. 1 by z plus 3, here also 1 by z plus 3, no need to multiply the minus. Now what is the first term here? The first term is your z. You just take common from these two terms. This is the beauty of this question, that after doing this, what will be the first term? You just just take the that term. Otherwise in this question, in the different books, they're not done in this way. So suppose 1 by z plus 3 is there, so z I am going to take the common, or 3 I am going to take the common. That will be give you the confusion. Okay, so by doing this, whatever the first term, no, that you are going to take the common. If I do so, then this will be 1 plus 3 by z, and you just check 3 by z, automatically it will always less than 1 in this region. Consider z is any point. Z is any point here. For the simplicity, suppose this arbitrary z will be considered on this real axis. Suppose we are going to consider -4. Put it over here. 3 by -4 less than 1. Or you can put 4 plus 4, 3 by 4 also less than 1. Or you can put 4.9 also less than 1. Or you can put 3.1. In this region 3.1 will be there, no, 3.1. 3 by 3.1 also less than 1. That means here 1 by 1 plus 3 by z, and this factor is less than 1, means what we can write? The so-called series of this one will be summation over n equal to 0 to infinity minus 1 to the power n 3 by z to the power n. Okay, and already 1 by z is there, 1 by z. Got it? Now we are going to find out Lorentz series of 1 by z plus 5. For this case, z dash is your what? Z dash is your minus 5. You stand over there. You stand. I drawn the figure. Okay, you just stand over there. Z0 is your 0. Now you are trying to move from this point into this region. That means any arbitrary point to this any arbitrary point. What is the situation? That means somewhere you are in the outside position and you are moving inside. That means out to in situation. So out to in case will be apply over here. Out to in case. For this case, for this, or in bracket I written shortly this is out to in case. Okay. So ls of 1 by z plus 5 will be written for the out to in case means z dash minus z0 minus z minus z0. Same thing, it has been written z dash is your minus 5, z0 0, z 0. Now after doing this, you just check, is it matched with the initial function, that is your 1 by z plus 5. Here you can see 1 by minus 5, this will be minus z. Not matched. If I will multiply minus, then it will match. So only for that I multiplied minus. Got it? If it will match, no need to multiply. If it is not matched, multiplied minus. Got it? Now then after you just consider the first term. What is the first term? First term here is the 5. Here you can see, here first term is just the z, here first term is the 5. So if you are not going to obey this method, maybe confusion will be created in your mind that here z is there first term, that means here 3 by z came and here z by 5 came in the answer, because in the books they are not given this method. They automatically taken here, they consider this format, z taken common 1 plus 3 by z. Why they taken they not mentioned properly clearly. Okay, so it will create the confusion. So by this method, what will be the first term? First term is minus 5. Take common outside. Take common from these two terms. We can get minus 5 taken outside 1 plus z by 5. Now z by 5 here for this case, it will be automatically less than 1. Automatically. तुमको कुछ करना नहीं पड़ेगा, ये ऑटोमेटिक हो जाएगा. Z by 5. Just you can check z by 5. You can consider any number in this region. For simplicity, this is the arbitrary point. No, arbitrary point को यहाँ पे ले लो, रियल एक्स में ले लो. रियल एक्स में लेके मैं सपोज मैं ले लूँगा -4 इफ आई एम गोइंग टू टेक -4 by 5 लेस देन 1. ओके ठीक है, मैं अगर 4 भी लूँ वो भी लेस देन 1 आएगा. 4 by 5 also less than 1. Okay, if I will consider just here 4.9 by 5 also less than 1, that means this is the less than 1. Then what will be the series of 1 by 1 plus z by 5 if z by 5 is less than 1? That is nothing but n equal to 0 to infinity summation minus 1 to the power n z by 5 to the power n. Already 1 by 5 minus got cancelled, 1 by 5 is there. So this is the Lorentz series of 1 by z plus 5 in this region. This is the Lorentz series of 1 by z plus 3 in this region. Finally, Lorentz series of this one, or 1 by 2 this minus this will be equal to here this one, Lorentz series of this one, or what is this value, 1 by 2 1 by z plus 3 minus 1 by z plus 5 will be equal to, you just put 1 by 2 is there, 1 by z plus 1 by z plus 3. Lorentz series is how much? This one, 1 by z minus 1 to the n, 3 by z to the n. Here for 1 by z plus 5, this one I just substituted. If you want, you can write in the expansion form. Here one interesting thing we got, whenever we consider out to in, we got only the analytic part. That means series which is called as the analytic part of the Taylor series. Here you can see this is power of z is your positive, but here in to out means power of the z is your negative. Got it? You can see this one. If I'm going to write this one, minus this one minus 1 to the n, 3 by z can be written 3 by z minus z0 to the power n, or minus 1 to the n into 3 into z minus z0 to the power minus n. हुआ ना? ये सारे के सारे जो भी जितने भी n तुम डालो वो सारे के सारे क्या होंगे, नेगेटिव वैल्यू होंगे ना. तो दिस इज योर प्रिंसिपल पार्ट ऑफ द लॉरेंट सीरीज हुआ. What is the case? We done this here. We done the in to out case, and for the out to in case here z by 5 to the power n, that means z minus z0 to the power n, that to the power n by 5 whole to the power 5 divided 5 to the power n. That means what? Here all the n's are the positive. That means this is the analytic part. So you just remember carefully, wherever you are going to use out to in, you are going to get the analytic part. For in to out, you are going to get the principal part of the Lorentz series only. Okay. Now, I told that at the end of this is the end of this question. Now, next class we are going to discuss this question number 11. But I told that at the end of this lecture, I will tell to you that what exactly you have to write in your exam for this question. Okay, for this question, carefully you have to watch. This question has been given. This question is a 6-mark question. What exactly you have to write? Here the partial fraction have been done, and I found that b equal to -1, a equal to 1/2. This partial fraction may you can do in your exam note, exam paper, or you can do this one in your rough. Okay, and you can get this one. Okay, you can get this one. Then for first bit, for z mod less than 3, you just draw the figure by considering circular method. No need to consider this one. You just consider by the circular equation. You draw this figure. After doing this figure, z0 equal this much, z dash here. For to find the ls equal to 1 by z plus 3, z dash is -3, z0 equal to 3. And the case is, from the figure clearly it is visible that this is the case of out to in case. So out to in case you just write at the here you can just write out to in case. Here out to in to out, this is the tricks that I have been told that easily you have to do your Lorentz series. So in your exam, may you can write, may not you can write. Out to in to out, keep in your mind that to write this one, the main function in this format. Or if you are going to write, there is no problem. Okay, so what you have to write? Find the Lorentz series of z 1 by z plus 3, z dash is your -3, z0 equal to 3. So hence Lorentz series of 1 by z plus 3 will be written as this one. Then these 3 steps. Okay, then find the Lorentz series of 1 by z plus 5. For this case, z0 equal to 0, z dash is -5. And this is the case of out to in. For out to in, 1 by z plus 5 will be equal to this one, and these steps, and like this much. Okay, so here these its singular point is at the, but we do not have to find the Lorentz series, but we have to find out the Lorentz series about z0 equal to 0 from figure blah blah. In detail, no need to write, here I written something say like that here z0 is 0 is not the singular point of this function. No need to write, only to the point you have to write. This is the first bit. Like you have to do for the second bit, only draw the figure, mention the z and z dash and z0, write the equation in the form of Lorentz series, that is the general equation, put the values and find the Lorentz series. Then just write z dash and z0 value and mention either it is in to out or out to in from the figure. Then find out the value. And here for this case also, for this case no, I written to the point. Okay, to the point. Here you can see for this case z dash z0, and we got the Lorentz series. For this one z dash z0, and we got the Lorentz series. Okay, like this you have to write. So if you do like this, then it will be reduced to 3.5 page, around 3.5 page. Okay, I drawn larger size figure. You just reduce the figure. Figure is, it will give you the idea where is your z0, where is your z dash. Okay, and it will be maximum three pages, three page this side, these 3 sides, 1 2 3. Okay, okay, thank you so much for watching this video. Write down the note what we have been discussed in this class, and ready for the next class. In our next class, we are going to discuss another important question, that is your find ls of fz equal to 7z minus 2 by zq minus z square minus 2z in these 3 regions. In detail, we are going to discuss in the next class. This is also one of the important question for your exam. Okay.